Hello, grade 9s. Welcome. This is lesson number 12. Okay, and today we're going to be looking at these vertical or horizontal lines. You can see 4 of them here. I named this bottom red one L1. That's a horizontal line, and so is this one, lines that lie flat like that. L1 and L2 are horizontal lines. So what is their slope? 0. We've been studying that now for quite a while. Notice that a horizontal line is parallel to the x-axis. You know, in fact, the x-axis itself is considered to be a horizontal line. And the y-axis itself is really a vertical line. Of course, so is L4 and L3. And so their slopes and the slope of the y-axis, we know doesn't exist. So we can say undefined. Sometimes we say does not exist. Mostly you guys like to use the word undefined. Now that's old knowledge. We're going to be investigating these kinds of lines a little more carefully. I call them special. They're a little bit, actually called them weird in my class the other day, because while they're just like all the lines we've been studying, they are a little bit special. So what we're going to do is we're going to list points that are on the line. See, if I start with L1, that's this line right here. I'm going to randomly make maybe 1, 2, 3, 4 points. Those are points that sit on the line. And every point that's on a line can be named as an ordered pair. So this point would be the point -6, comma, -8. And so I'm going to put that in this table. This is called a table of values, and it's a way of putting ordered pairs that belong to this line. Now, we've always done that when we had an equation, and then you had to find the solutions to those equations. This is a little weird. I told you, we're going to go backwards. I'm going to put all the points here, and looking at them, we're going to guess the equation. So let's take a few more because we want to see a pattern. So if we take this point, it's -4, comma, -8, and I'll put it in the table instead of writing it as an ordered pair. This point is the one everybody messes up. Be careful. It's 0, comma, -8. This point over here is that 3 or 4? Looks like 4. 4. And look what happens, because it doesn't really matter where you stop. No matter where you stop, the y is always -8, which makes perfect sense because you can go over 10, but you're going to go down 8. You can go over 2, but you have to go down 8. Every single point here is a y coordinate of -8. Every single point, no matter which one you pick. Guess what the equation is? Y equals -8. That's his equation, which is what I call a weird equation because we're very used to having x's and y's. So here I gave you the points, and then looking at them, I told you guys the equation has to be y equals -8, which I call weird because it's missing an x. The truth is, it's not really missing an x. It's really this equation. And it's kind of weird, and we're going to have to get used to it, and it's new. But my point when we do this is that when we get equations that match with either vertical lines or horizontal lines, they're only going to have one letter. So look at L2. I'll take these random 4 points, okay? This is the point 0, comma, 3. Way over here would be -8, comma, 3. This one is over 4, up 3. See what's happening? And then, of course, this one is 10. So what do you think the equation of this is based on the pattern That's right, I can hear you yelling. It's y equals 3. I mean, it's really 0x plus y equals 3, but nobody writes the 0. And so it's going to be true that whenever you have a horizontal line, the equation looks like these. So I know right away if I have y equals 20, that's a horizontal line. If I have y equals 8, that's a horizontal line. If I have y equals 1/2, that's a horizontal line. Horizontal lines always have equations. Y equals some number. Could be a 3, could be a -5. It's kind of weird, but I memorize it this way. I go, these are special cases. So I'm memorizing, I can see where it comes from, but I'm memorizing the unusual equation that matches with the horizontal line. It's always y equals because it hits the y-axis. That's why y always equals 8 or y always equals 3, because that's one way to remember it. Okay? It says use the points. That's what I did here. So let's try L3, which is entirely different now because L3 is a vertical line. So if you look at this and you take, say, a point here or a point here, I'll take those 4 dots. 1, 2, 3, 4. This point would be, it's sitting on L3, I go over 7, up 6. This point is over 7, up 3. This point would be 7, 0. This point, 7, -4. You could pick whatever point you want. You're going to have to go 7 units over, and then you'll go up, or you'll go down. Isn't it weird? But every single point that's on this line has an x coordinate of 7. And guess what his equation is? X always equals 7. That's how I say it, right? X always equals 7. So I'll put that here. Line 1, y always equals a -8. Line 2, the y always equals a 3. And when you do line 4, again, you pick a few points just to kind of get the pattern. If I want to name this point, I have to go to the left 6 and then up 0. This point, go to the left 6, up 3. Right? 1, 2, 3. This point, that name is -6, -3. Left 6, down 3. You could pick any point you want. You're going to have to go left 6, and then you'll go up as high as you need to. And so when you have a vertical line, every single time you get to a point, you have to go -6. Then you can go up or then down. The x coordinate is always -6. So it's really why I call them the weird lines. We know about their slopes. Remember, slopes are one idea. They are straight lines. They have lots of points. Remember, each ordered pair represents a point. And every line always has a matching equation. We're used to equations that look like this. That's what we're used to. But these are just as acceptable. And while they do look really weird to you, these equations are they really do have an x and a y. If you have x equals 7, that's the same thing as this. So I'm trying to get you used to equations that are missing a letter. But if it really bothers you, you really want to see an x and a y, it's okay. Fill it in, whatever's missing. See? If the y letter is missing, fill in a 0y. If the x letter is missing, say for this one, fill in an x, like that, with a 0. But you're basically really going to save yourselves a lot of aggravation if you just look at this video again and memorize that we have vertical lines that are kind of weird, and they always have this kind of an equation. X equals 2, X equals a half. They're just a little weird. And that's because the x is always that number. Memorize it. So what are we going to memorize? We're going to memorize that vertical lines have undefined slope and always have an equation x equals some number. Could be a different number. Horizontal lines always have a slope of 0. They're always flat. But if you want to talk about their equation, they always have an equation of the form y equals. So it is memorizing, okay? So look at this up here when you get confused for the questions that we're going to do right here. It says graph the line. What this is saying is, okay, it's missing a letter. I know it's a special case. The way I say it, oh, it has to hit the y at 3, and then it's a horizontal line. And I know it's a horizontal line because it only has one variable. This is going to be a line. It's one of the special cases. If you get confused, is it vertical? Is it horizontal? You go to where x is -4, and x always has to be -4, and you get a vertical line, okay? Look at that. What is that? It's not the same as this. Well, sure it is. If you throw the 6 over to the other side, y equals 6, horizontal line. Throw the 8, x equals -8, oops, sorry, vertical line. It's memory. It's partial memory, but of course when you start to understand it, when you get used to it, it won't be quite so bad, but it is kind of hard to remember it. That's why you have to save your notes. So let's try another one. Now, when you have a line that's missing, you have equations here that are missing a variable, that's when we know it's vertical or horizontal. But when you have a line that has both variables, those are the kind that we were doing until this point, which they can go down or they can go up. They're called oblique lines. Those are lines that are not vertical and not horizontal. So if I look at this, I've memorized y equals, hits the y-axis, it has to be a horizontal line. But x equals, I've memorized it, has to be a vertical line. This only has the letter y. It has to be a horizontal. This has both variables. This guy is an oblique line. This only has one variable, the letter x. It's a vertical line. This has both variables. It's an oblique line. Okay? So what if I say to you, I have a line. Here's the equation. Now I'm going to start to try to get you used to these new kinds of equations that appear to be missing a letter. When you have the equation y equals 17, that is a line. Okay, I can't graph it because I picked a big number. If we make an approximate graph over here without using a grid, 17 would be quite high. That's where y is 17. That's a picture of what this line looks like. Every equation has a picture, a graph. The points that are on the line can be anything you want as long as y is always 17. So if you want x to be 1, go for it. Y has to be 17. If you want x to be 23, go for it. Y has to be 17. If you want x to be -0.1, go for it. Y still equals 17. In other words, you can put whatever number you want. The y has to be 17. It's really weird, but that's how you get a horizontal line. And so what do we have to know? We look at this, we go, oh, one variable, special case, that's a horizontal line, looks like this, has a slope of 0. Here's some points that are on that line. 0, 17, -5, 17. I could do it all day. I didn't even leave enough room. When you look at this, what should you know? You say, oh, only one letter. Lines that look like that are vertical. This is a vertical line. So if I make it, here's 20, way over here on the x-axis, that's what the line would look like. It has no slope, undefined slope. Points, x has to be 20. Y can be whatever you want, but the x has to be 20. The x has to be 20. The y can be whatever you want. And you could do this all day. It said make up 5, so 20, negative 0.1. There you go, 5 points on that line. It's really weird, and you kind of have to memorize it. You kind of have to practice it. And now we go to the last question. So again, I want the slope. You have to remember what this line looks like, otherwise you can't tell me the slope. You got to memorize it's horizontal, flat. The slope of it would be 0. Remember what the slope of this is? Throwing an oblique line at you. This is in the form y equals mx plus b. M is going to equal 2 because that line is going to be an oblique line. It's slanty. It's not vertical and it's not horizontal. You look at this one, you go, oh, special case. That's got to be vertical. There is no slope. It's undefined because it's a vertical line. And this is an oblique line. You remember how to get the slope? It's minus a over b. So there's a little bit of the old mixed in with a little bit of the new. And now there is homework attached to the, or posted under contents that you can do to see if you can understand these concepts. It takes a lot of practice.